Welcome. This is Start Logic and Algebra. We're going to be starting with logic. I am Dr. Lois Adewoye Ademola. In this chapter 1, we're considering conjunction, disjunction, negation, conditional statements, biconditional statements, quantifiers, and methods of proofs. And thereafter, we'll consider some examples. I should also note here that we'll also be checking when verifying when a statement lands in or results in a contradiction. So we begin with the definition. So a statement is any collection of symbols which is either true or false, and they are usually denoted by lowercase letters, as you can see on the screen here. Could use P, Q, R, X, Y, Z, but lowercase letters. Now, what's a compound statement? A compound statement, or another name for that, is a propositional logic. So you note that you can call it a propositional logic or a compound statement. Now, it's composed of subsets and various logical connectives. Okay. Now, the first logical connective we're going to be considering is what we call a conjunction. A conjunction has to do with when you have statements P and Q and the symbol like a cap. This is called a conjunction, this symbol, which is what you see in the table. Okay, so the truth table for a conjunction is what you see displayed here. Now you have statements P and Q. Okay, so you have the statement P and Q here. When you have two statements, your entries under P are always T, T, F, F, as you can see on the screen. Always under P, T, T, F, F. That is true, true, false, false. And under Q, the statement Q, it will always be T, F, T, F. Okay? Always. Don't mix them up. Don't interchange them either. It's always T, T, F, F, and then T, F, T, F for Q, because there are just two statements P and Q. Okay, note that. So once we have two statements, the entries under each of the statement P, Q, or it could even be X, Y, or MN, would always be for the first statement T, T, F, F. The second statement T, F, T, F. Now, whenever you combine two statements, say P with a conjunction, upside down letter V as it were, which is a cap, you connecting two statements P and Q, the results are what we have here. And this is because you connected this way. So let's see how we connect them. So when a statement P is true and the statement Q is true, it means that the connection of these two under conjunction is always true. See that? Now, if the statement is true for P and the statement for Q is false, it means that so long as one of the two is false, the connecting the two together will always result in false, being a lie. So if it turns out that if the statement P is false and the statement Q is true, because one of them is false, it will always be false when you connect P and Q under conjunction. And also, if both statements are false, false, means that your final result will always be false. Okay, so all you need to note is that when statements are connected by the conjunction, that so long as you have it to be true for the statement P and true for the statement Q, once you're using the connective conjunction, it will always be true. If it is true for the statement P and false for the statement Q, it means that the statement, when you combine the two together, will be false. For instance, if you have two children in a house, one is Pedro and the other is Quinty. If Pedro in the house said he did not take that, the video camera, you saw in the video camera that he did not take the the item, okay? And Quinto said that he took the item, as in pointing that Pedro took the item. Now, by the time you consider the statement of Pedro, he did not take, and Quinto, who claims that Pedro took the item, now that Pedro's statement is true and Quinto's statement is false, before you check the video, so long as Pedro's statement is true and Quinto's statement is false, because it's possible Quinto took the item, by the truth table conjunction, if you take Pedro and Quinto with the connector, and the conjunction statement, another name for it is and, by the way, and, so P and Q. So when you use that, the true, so you look at your table, I said Pedro's statement was what? He said he didn't take it, right? And Quinto said he took it. That is, Pedro took it. So if we are not sure who took it. So supposing we assume that Pedro's statement is true, and Quinto is saying it is true that he took it. Well, what if it was Quinto that took it? So my example is not so good. However, so long as Pedro's statement is true and Quinto is false, it means there is something wrong somewhere, so the statement will be false, okay? As we continue, I'll think of a better example. But however, all you need to know is that once you have the connector, conjunction, another name which I said is and for it, so if you have the statement P and Q, combining the two statements, if you happen to have the statement, the final values, whenever you have T on P, Q being T, the final value must always be true. So all you need to know is to know this table by heart, okay? Just know the table by heart, that for a conjunction, the and statement, it is only true whenever both statements are true, as you can see here. It's only on the condition that both statements are true, that connecting the two statements will always give a final answer true. Else, every other thing will be true for the conjunction statement, which is symboled here, and in letter form it is called and. Okay, so that's what you need to know about the conjunction. So remember, both statements always true means your final answer will be true, else it will always be false. The next you need to know is what we call the disjunction. For the disjunction, again, we have two statements, P and Q, and like I said before, under P it will always be T, T, F, F. Another Q will be T, F, T, F. Now, for the conjunction, another name for this conjunction is OR. Okay, OR. So if you have that, and the symbol form is what you see here, like a letter V. So if you have two statements, P or Q, because the statement is true and true, let me clean it so that you can see that. So like I said, you have two statements P and Q. Because you have two statements, it will always be 4 entries, which is T, T, F, F under P, and T, F, T, F under Q. Okay, so now for the disjunction, which I said the letter form of it is what? Is OR. Okay, once you have two statements, it is only true. Okay, it is only false when both of statements are false. That's for disjunction. That's the OR statement. If both statements are false, it means it will be false. Else, even when it is false, all the statements will be true. So the difference between conjunction and disjunction is this. For conjunction, it will always be true only when both statements are true, else everything will be false. But for disjunction, whatever, so long as one person said the truth, it is true. But if both statements are false, then it will be false. Okay, so it's the opposite of it. So that's the two for the connectives. We've done conjunction, and now we've seen disjunction. And now we have the negation, which is this tautology, okay? Meaning the negation, the opposite of the statement. So it just has two entries, which is T and F. Okay, just two values for P and two values for the negation of P. So when it is true, it means the negation will be false. When it is false, the negation will be true. For instance, Pedro is fat. What would be the negation of Pedro being fat? It will be Pedro is not fat. That's just it. Okay, so let's move forward. The next definition you need to know is what we call the conditional statement. For the conditional statement, as we move forward, I will give you other ways that this is written, and the symbol for it is this implication statement. Okay, so for the conditional statement, it's just if then. It's an if then statement. So if I have P, then Q. Okay, that's what it means. But there are other ways of writing the conditional statement. Okay, so what does that mean? So we have two statements, P and Q, which I said before, you have T, T, F, F, always. And then the Q will be T, F, T, F. Okay, so now if the entry is true and it implies that Q is true, note the arrow is pointing towards Q. I want us to be careful with that arrow, being careful with the pointing of the arrow. So I said it's if then, right? So if P is pointing towards Q, note the direction, okay? So T on P and T on Q means the answer will be true. T on P and false on Q means the answer will be false. False on P and true on T means the answer will be true, because it is pointing towards the final value here. Note this one. But now one very thing you need to be careful with is when both of the statements are false, that's in FF. Once they are FF, the final answer will always be true. Look at it. So be careful. When both of them look the same, your final answer will always be true. So you need to be careful there. So it is pointing to true, it will be true. If it's pointing to F, it will be false. That's true to F. When false is pointing to true, then the answer will be true. If it is pointing from false to false because both of them told a lie, it means they are correct. They actually told it right. So the statement will be true. Don't worry, as we continue practicing, you'll see how we use these truth tables. Okay. The next and final connective you need to know is what we call the biconditional statement. For the biconditional statement, all it means is that once the two statements are true, it will be true. Once the two statements are false, it will be false. But if both statements, one being true, one being false, or false and true, it means they will always be false. Okay? So that is all for the biconditional statement. Again, for the biconditional statement, once both of them are true, the final answer will be true. If both answers are false, the final answer will be true. But if both of them have different answers, one true, one false, then everything will always be false, as you can see at the final values here. Okay, that is all for connective and what you need to know on the connectives. Okay, like I said earlier on, I said for the conditional statement, the if only, if I remember, I said if then. If P, then. Now there are various ways of writing the same thing. So the various ways are, it could be pronounced as if then, Q if P, Q whenever P. It means just the same thing, all the same there. Q provided P, whenever P then Q. P is sufficient condition for Q. For Q it is sufficient that P. Q is a necessary condition for P. For P it is necessary that Q, and P only if Q. So those are ways of writing the same sentence. It just means this P implies Q. So you need to know them by heart. Okay, there's another thing you need to know, and this is what we call converse of a conditional statement, inverse of a conditional statement, and contrapositive of a conditional statement. So these are key things you need to know. Okay, the first is what we call a converse. Note what happens when they tell you to get the converse of a conditional statement. I now had explained to you what a conditional statement is. It is the one that says if P then Q. Is that also with the arrow pointing this direction, right? Okay, so once you are told to find the converse, it means flip them. The converse, flip it. So you can see that Q has come, it now became Q implies P. So if you're told to find the converse of Peter is tall, then Lois is short. The converse will be what? Lois is short. If Lois is short, then Peter is tall. Just the opposite direction of it. Don't worry, you will see us use more of these examples as we continue. Okay. The next example is, the next one you need to know is the inverse. For the inverse, note, look at it carefully. P implies Q. You simply just put the negation of P implies the negation of Q. So that's just what you're to do. Like the example I had used earlier. If Peter is tall, then Lois is short. It means if you're told to find the inverse of that statement, you say, if Peter is not tall, then Lois is not short. Did you see that? For the contrapositive, it simply means you are basically flipping and then you take the negative of the two. See? You flip the Q to the other side. That's the contrapositive. Contra first, then you do like converse. The contra makes you know. Then positive, change the values to the negative of it. So you flip Q to the other side and P to the other side and take the negation of it, and then you have the statement. That is to say, with our example we were talking about, if Peter is tall, then Lois is short. What will be the contrapositive? It will mean that if Lois is not short, then Peter is not tall, because that is what we are looking for. Don't worry, you can go back over the video a second time to get a better understanding of it. So how would the truth table look like if we're to combine the converse, the contrapositive, the inverse, everything together? So let's see how the truth table will look like. Okay, so what do we need to get our truth table? To generate this truth table, to generate the truth table for the converse, the inverse, the contrapositive, we simply study our final values that we need here. Okay, we have two statements, P and Q, so our entries remain the same: true, true, false, false, true, false, true, false. Remember what I kept insisting? I said it always stays like that once you have two entries, meaning that if you have 3 entries, you will have how many entries? 8 of them. Okay, that is because we have 2 to the power 2, 2 to the power 3 as our entry number. Okay, don't worry, we'll do an example for the 3 entries later as we continue with the video. So now we want to get the truth table for this particular converse, inverse, and contrapositive. So for the converse, we know converse is the flipping of it, which is Q implies P. You can see it here. But first, before you can get Q implies P, you need to find P implies Q, right? So there's P implies Q here. Then the converse is here. The inverse is right here. Can you see the inverse? Just negation of the original statement. And the contrapositive, which is negation, you flip first and then you take the negation, right? So you have it there. Okay, so we need to build this table based on your knowledge of the conditional statement. Remember what conditional statement does. Remember that the arrow points this way, right? Let's go backwards so you see what I was explaining earlier. So this is the conditional statement, right? So we said when you have P implies Q, the arrow is pointing this way because truth is pointing to truth, the statement remains true. Because false is pointing to false, the statement remains true, just like we have for the biconditional. But in the case of when we have the values different, once the truth is pointing to the false, it means it will be false. The final answer must be false. But once false is pointing to the truth, it will always be true, as you can see on the screen. So let's go back to where we were when we're trying to build the table. So now remember, you have 2 entries or 2 statements. So we have true, true, false, false, and truth, false, truth, false. Okay, so we need negation. That's why we need negation P. Look at it here. We need negation Q. We have written it here. We need P implies Q, because that's the next thing. Basically like your board maths with brackets, you understand? First addition, bracket, off, multiplication, something like that. So we want to be careful and arrange them. Okay, next thing we need is we need to find Q implies P, which is this one here, right? So we have it here. So we need negation P implies negation Q. Look at it here. And then finally negation Q implies negation P. Okay, I will take the entry for, I will show you how this last one is gotten. The last entry here is gotten. Okay, so first, because we need negation Q, we need to find negation Q, and we need to find negation P, as you can see here. Okay, so what is P? We know P is truth, negation of P when it is true is going to be false, as you see there. What is P when it is true again? It's going to be negation of true, which is false, right? And P is false here, so the negation will be true. It is false here, so the negation will be true, as you can see on the screen there. So we need to find negation Q. So how do we find negation Q? The value of Q is right here. So Q is truthful here, so therefore it's going to be false here because we're looking for its negation. It is false here, so it becomes true here. It is true here, so it becomes false here. It is true false here, so it becomes true here, as you can see on the screen. Okay, so we have found negation P and negation Q, but our target is to find what? I want to clean and make it clear for you. Our target is to find the contrapositive, which is what I said I was going to solve for you. You can go through and ask questions on the WhatsApp as we continue. So I'm solving this, right? Okay, so now we're now looking for when negation Q is pointing to negation P. You can see that negation Q will be pointing to negation P. See that? So let me clean so that the screen will be clear. At least you can see what I'm writing. So we're looking for negation Q when it is pointing to negation P. So it means that negation Q is pointing towards this direction, right? Pointing this direction, not the other way. Okay, so false is pointing to false, it will be true. Can you see that? Negation Q pointing this way again. Truth is pointing to false, it will be false. Is that not what we said? Once it's pointing to false, it will be false. False is pointing to true. What will be your final answer? It will be true because the false is pointing towards the truth. Oh, again, we have truth pointing to true. Clearly, it will be true. So that's how we got the values here. Okay. Let's try this one. Let's try Q implies P, and let's see. Let's try Q implies P. For Q implies P, it means Q is pointing. Let me clean it quickly. For Q implies P, it means that Q is pointing towards P. Okay, so Q is pointing this direction right now. Okay, so truth is pointing to truth. That's my table. The value is true, which is correct, right? False is pointing to true. The value will be true because we said it's pointing to true. But now truth is pointing to false. What do you get? It will be false. And false is pointing to false. The value will be true. So that's how we got the entries. You can try and verify this yourself. And if you have questions, ask on the WhatsApp platform. Okay, let's move forward now. Some things on definitions you might need to know, or you need to know, is what we call tautology. Tautology simply means all the final entries of the truth table will be true, everything. So maybe if you had some entries P, cap, negation, Q, and the first, since they are two-trace statement, you get T, 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 and T. Then we say we have a tautology. Okay. And now the next thing you need to know is that a propositional function is an assertion which is no longer true or false, but becomes so when particular values are substituted for the variables. Okay, so if an assertion involves x, we denote it as px, more like a function, right? And if this assertion holds for all x, we write for all x, px holds. Okay, this symbol here, it means for all. Okay, that's what meaning for all x, px holds. Okay, we then say the variable x is bounded by the universal quantifier. So we say it is bounded by a universal quantifier. So if I ask when is a variable x set to be bounded by a universal quantifier, you just simply state this: for all x, px holds. Okay. The next statement you need to understand is that if we say px holds for some x, we write that there exists an x, that this symbol means there exists. Okay, there exists an x such that, this is such that, you can see that it's curved, px holds. Okay, that's how we write it. That's how we denote it. And in short form, this is how you write it in short form, meaning there exists x such that px holds. We then say the variable x is bounded by a universal quantifier. So if I say, when is a statement, when is a variable x bounded by a universal quantifier, okay, you will now be able to say that it is when we are able to say this statement here, there is this x such that px holds. Okay, so it is bounded by an existential, not universal, but an existential, because that's what is there, existential. If I say universal, then you will use this one here, this particular one here for universal. Okay, for existential, you use this one, you use this. Okay, now there are various methods of proofs we use in abstract algebra, and we just briefly mention them because I could ask you to list the various methods of proofs. These methods of proof includes a direct proof, which we call modus ponens, an indirect proof, which is basically proven by contradiction. Another name for proof by contradiction is called the reductio ad absurdum. We also have proof by counterexample. Once you can get an example that will negate what someone is saying, you have proven by a counterexample. Another thing you need to know is what we call the quad erat demonstrandum and the quad erat faciendum. These are basically terms used at the end of proofs. Okay, you can check your notes for further explanation. The class rep is to get the lecture notes for you. So quad erat demonstrandum used at the end of a proof, which is just a box, most times symbolized as a box, or you simply write quad erat faciendum. Okay, so that's what we mean, Q E F. Okay, that's basically the end of a proof, symbolizing the end of a proof. Okay, we have some examples to consider now, and we have 4 of them. I think I get there are 5 of them. Anyway, let's see if it's at the end, we'll work with that. Okay, so we're to establish the equivalence of this statement. So we have 2 statements. We have that you should basically, you're going to form the truth table of P cap Q negating of this P cap Q, and then you form the truth table of negation P or negation Q. I'm sure you can, like I said before, you can rewind the video and go back to the beginning so that you can remember the truth table for this, for the conditional statement and the biconditional statement. Sorry, and the biconditional, the conjunction and the disjunction. Sorry. Now the conjunction, if you remember, it's only true when both of them are true, and the disjunction is only false when both of them are false. Okay, so once you find this truth table and you find this truth table, you then check if the 2 values are the same, and once they're the same, you have shown the equivalence. This simply means show their equivalent. So if you had 3 of them, maybe there's another one here, you just form the truth table of the third one and check that the values are, the final truth answers are the same, truth table answers are the same. Okay, and then we have one here that we should, the second one says show that this thing here, this combination of statements, is a tautology, meaning that the final values will all be TTT all through. Okay, and then this one, we're to construct this truth table, and after constructing, we should establish that we'll get a contradiction. Okay, the next one says determine the contrapositive of each of the following. So contrapositive, what are contrapositive? Remember the contrapositive, we said you have of a conditional statement, you have P implies Q. It says we should flip it first. That you flip it, and because it is having positive there, you negate the 2 of them. That's a contrapositive. Okay, that's what you're going to find of the truth. I think I missed out a 5th question, but let's continue, and if it comes up, we solve it. Okay, let's go on now. So solution to number 1. So like I said before, you're going to find the truth table of this. You can choose to separate the 2 tables, but I have merged them together. Okay, how did I do that? First, I checked what I needed. I have 2 statements here because there are 2 of them, P and Q. That's all I see I needed there. What do we need? We need negation P. We need negation P. We need negation Q. we need P cap Q, we need negation P cap Q, is that? We need negation P or negation Q. That's the last thing we need. So as you can see, everything is written here. The P, see P here, Q is here, negation P here, negation Q here. P cap Q, see it here, negation P cap Q over here, and negation P or negation Q, which is here. I got them all from here. I'll show you again. I'll take it from the start. So to solve this, we want to form the truth table. Like I said, I merged them together to get them. So I need to check here for everything I need here. I see we need P, because there's P here. We need Q, because there's Q here. You can see that? Then we need P, combining them together, the two statements, because the two of them are combining here. You can see that right in the bracket. Then we need negation P in the bracket, everything, all of this statement here. That's how I got this first line, all of this. For this one, I see we need negation P. We need P. P is already there. We need P. We need Q. We need negation P, because you can see we need P and Q. We need a negation P. I've got a negation P. We need negation Q. Look at it right here. And then finally, we need this one that I've written down here. Okay. So everything, I just arranged them and brought them in columns, as you can see on the screen. So let me clean this. Okay. So I haven't written each one. P, Q, negation P, negation Q, P cap Q, which is what you have here, negation P cap Q, which is all of this, and then negation P, you can see here, and negation Q, and the entire statement is here. So everything here is what you have here, and everything here is what you have right here. You can see that? Okay, so we want to verify that the final values will be the same. So how did we get this? So we'll take it step by step for you. First, remember I said once you have two statements P and Q, the entries always be for P, T, T, F, F, as you can see on the screen. For Q will always be T, F, T, F, as you can see on the screen. Okay, the next thing is to check this column with negation. Check this column, negation P. What is negation P? Is the opposite of P, is that not so? When P is true here, it becomes false, right? When P is true here, it becomes false again. When P is false here, so this is false, right? It becomes true. When P is false here, it becomes true. You can see that? So that's how we got the entries you see there. So I'm going to claim it since it's typed up already on the screen. Okay, so we stopped at, we've done this, we've done this, we've done this. Next, we want to check negation Q. For negation Q, we check on the Q. This is Q here, column of Q. Okay, so when Q is true here, what is the opposite of it? It will be false. So I'm going to write false. Let me just write false. There. It'll be false, right? When Q is false again, so false, what happens? It becomes true right here, right? When Q is true here, what happens? It becomes false because we're looking for the opposite of it. When Q is true right here, it becomes true. Sorry, false, it becomes true. Okay, can you see that? I hope you understood what I've done there. So that's how we got for negation Q. So we've done all of this here. Okay, so we're now here now. We need to find P cap Q, or P and Q, or P conditional statement Q. Is that also a condition Q? But we always say P and Q, okay? So we need to find this. Now, what is the truth table for AND? We know that for AND, if you have P, Q, when it is true and true here, the P and Q of it is saying that once it is true, it will always be true. Every other thing will be false. Is that not so? So let's check. For this first, P and Q, they're both true, so definitely will be true, right? If it's not true, everything will be false. So now one of them is false, it must be false. Agree? One of them is false again here. See, this one is false. So my answer here will be false. Agree? So this is true here. And both of them are false for the conditional statement, and it will always be false. So the only condition that both of them will be true is that both you get true as your final answer is that both of them are true statements. So we finish this table for the cap. Okay, the next one entry we need to check now is the negation of the cap. So we want to negate this one because that's what we've done in the bracket, right? Everything in the bracket here, you want to take the negative of it. So the negative of it is, this is true, definitely this will be false. This is false, this will be true. This is false, this will become true. This is false, this becomes true. Agreed? Okay, next thing, so we're through with this one and the final column. So our target is to verify that this answer, the answer to this entry, and this will be the same. That's why there's an equivalence here. Okay, you want to check if they're equivalent. So we're now at the last column. Okay, so let's check the last column. We need to find negation P or negation Q. And for the or, the only time when it is negative, everything will be true. Is that also for the or statement? Now this or, if this was to be or, this would be true be true, true and false will be true, right? And false, this is false, right? And this is CF. That's what I taught us before. So false and true will be true, and this definitely is false. That is what we said for the or statement. That is the bijection, bicondition, by disconjunction. What am I calling biconditional? Mixing the two together. Okay, so let's continue now. So we are now at the disjunction, which is this conjunction, which is also known as the or statement. So we want to check this. So, but then we're looking at P or Q. So this is P, this is Q, right? So the or, both of them are false, definitely false. One of them is true. Because it is an or statement, it will be true, right? Both of them are false. This is true. Sorry, both of them, one of them is true. So this is definitely going to be true. Both of them are true, definitely going to be true. So we're through with the entries for each of the columns. And so we've finished the entire truth table. That's how you build the truth table. So let's see now. Are they equivalent? So check. This is false, false, correct. True, true, correct. True, true, correct. True, true, correct. Therefore, they are equivalent. So that's all to the table. So you just simply put your arrow to make me know that both of them are equivalent, and you're done with the proof of this solution or completion of the solving of the problem. Okay, next one, question number 2 has how many statements? Let's look at it. We have X, we have Y, we have Z. So we have 3 statements. 3. Once we have 3, we're basically taking 2 to the power 3, so we have 8 entries. 8 entries in this form. See, T, 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 F, 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 F. Okay, so we have 3 entries, X, Y, Z. We start with the first statement, which is X, right? So we have X, Y, and Z, as you can see there. Okay, so like I said before, once we have 3, we have 8 entries. So we have T, 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 4 of them, and 4 F's, F, 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 F. After we do T, T for Y, F, F, T, T, F, F. So you need to know this by heart. And the last statement, which is Z, will be T, F, T, F, T, F, T, F. Okay, so we have found the 3 statements. What else do we need? So let's see what we need. Now that you know what happens when we have 3 of them, what do we need? So we check our question. Our question has 3 statements. We need X, we need Y. So we need X, we need Y, we need Z. So let's use board maths. We go into the bracket. What do you see next when you use board maths? The next term we need is this one inside the bigger bracket, which is X, implies y. Have you seen that? This one here. Then afterwards, we will need the next bracket. See the next bracket? This bigger bracket here. This one here. Next, we will need x, or x implies y, which is the next thing you need, all of this. And finally, you will need the entire thing, everything. So you will need x, or x implies y. We close the bracket, and then we put all z. So all of this must be there. So let's check what I have typed here for you on the screen. We have x, x, y, y, z, z. X implies y, done. X or x implies y, see it right here, and finally the very last entry itself, which is all of this. So that's how I got the table. Basically, using the concept of BODMAS. You go in the bracket and pick the terms one after the other. Again, we have 3 statements. With 3 statements means we have all the entries you see there with 8 of them this way, and then we go 2, 2, 2, 2, and then 1, 1, 1, 1, starting with positive. Okay, so we have the 3 of them, and the entries we needed are already on the screen. And now the first one here is x implies y. Can you tell me the truth table for x implies y? Let's see how it will look like. So let's recall something quickly and before I start solving. So if I happen to have x and y, if I have 2 statements, it means I have t, t, f, f, right? And then I have t, f, t, f. And we're looking for x implies y. For x implies y, t, t means it will always be true. It's pointing, right? It's pointing to true. T is pointing to f, definitely it's going to be f. F is pointing to true, definitely going to be true. Is that not so? And f is pointing to f, it will be true. So that's your entry for the truth table for x implies y. So now let's use this concept, okay, shall we? Okay, we use the knowledge of this to find this our x implies y here. So we go to x in this row. X is true, y is true. It means that x is pointing to true, it will be true. Agree? X is true, y is true. It's pointing to both, it will be true. X is true and pointing to false, it will be false. X is true, pointing to false again, it will be false. X is false, pointing to true, it will be true. X is false, pointing to true, it will be true. Okay? Now, both of them are false, pointing to false, definitely true, because we're working with conditional statements, right? False pointing to false again, it will be true. So that's how I got that entry there. So we're true with this. We'll move to the next column. For the next column, we're looking for this one, which is x or x implies y. So we have x implies y, it's over here, and there is a conditional statement, a connector or. So for the connector or, we know now that for or, let me write that. If you remember, if I happen to have x, y, we have t, t, f, f, t, f, t, f, when we have 2 of them. So we were looking for when we have x or y. For x or y, once it is true, they remain true. One of them is true, true. One of them is true, true. When both of them are false, that's when you get false. Is that not so? So that's what we're using. So let's use that now and solve. So we need x or x implies y. So this x implies y, and this is x here. So working with that. This is true, or, and this is true, means definitely true. Both of them are true. Or, now t or t, definitely true. T or false, because it's a or, it is true. T or false, definitely true, because one of them is true. False or true again, one of them is true, it is true. False or true, one of them is true, it is true. False or false, both false or false. Oh, there's a mistake here. False or false for all statement. What did we say it would be? It would be false. Okay, not true. And then false or false again, it is not true but false. So there's an error here. Okay, now let's continue now. So make the correction. This is wrong. What I typed here, the entry is wrong. Okay, because there is an or statement here. Okay, you saw the connectors. So we are going to adjust that. So let's clean what I've done. It means it will affect the final value. And so let's write it correctly now. Don't use this last entry. I'm going to write it as it is. So this is false here. And this is false here. These entries are not correct. Okay, so using this new values, we continue. Okay, so let's solve now. We're working for the very last one now. The last one has the or connector right here. See the or as a connector, and it's connecting. Sorry, right here at the back here. Sorry, is at the back, right there. So the connector is joining this and Z. Okay, so we connect the two now, and but it's an or connector. Again, the or connectors tells us that it's only when both of them are false that they will be false. Everything is true. So let's go now. Let's go ahead. So Z is true. Well, let me go like you have it on the screen there. Let's start with the longer, bigger one. If this is true and this is true, definitely it is true. So we got it now. It's an or statement. This is true or this is false. Because one of them is true, it is true. This is false. Oh, sorry, wrong location. So you have to be careful. If I'm making that, you also be careful. This is true and this is true. Definitely, sorry, not and, but or this is true. It is true. This is true or this is false. One of them is true, so this is true. This is true or this is true. Both of them are true, so this is true. This is true and this is false. One of them true, it is true, because there's the or statement. This is false and this is true. What does that mean? It means this is true. This is false and this is false. Oh, this is not true, so this is false. We have an F right at the end there. Therefore, it is not true that this statement is a tautology. Okay, so not sure, but I will change this question to verify. Okay, that this is a tautology. So it is not. It is not a tautology. So everyone can make the correction, and if we see this again, please ensure that we note that. Okay, let's continue now. The next one says construct the truth table for this particular case. I want you all to attempt this on your own. It has been solved with everything I've shown you earlier on. You also try it and see if you can do. Any questions, ask via the WhatsApp. So go through it, note how many things you need. Clearly you need P and Q, so insert everything as necessary and complete the table. You can pause the video later on. Okay, I was saying that there was one more thing and I didn't say it, so I didn't paste it in front there, which is what we have here. It says determine the okay, no, that's the fourth question, right? Okay, it's the fourth question, it's not the one. Determine the contrapositive. What is contrapositive? It is what you have here. Come in. So it says determine the contrapositive. What is contrapositive? It is the one right here. You flip them and put the contradictions, the negation on each of them, okay? So we're looking for the contrapositive of each of the following statements. It says, if Julius is a banker, then he is rich. So we have if, then. If Julius, so if, then statement. This is clear, and if, then. So let P be Julius is a banker. Then he is rich. Let Q be he is rich. So what's the contrapositive? So we have that P implies we see the contrapositive, and the contrapositive is simply this, right? So if negation of Q means that it is false that he is rich, is that not so? Or simply he is not rich. And negation P means if it is false that Julius is a banker, or simply Julius is not a banker. Okay, so the conclusion is that if Julius is not a banker, then he is not rich, which is your final answer. Okay, you can read through it and run through. The video is quite a lengthy one, but you can go through. In a similar way, you can do the example for the second one and attempt it on your own. Okay, thank you very much.